Hello. You might have seen questions with statements like all A's are B's, some B's are C's, etc. These kind of questions, which are logical in nature, are usually called syllogism questions. Some people call them deduction questions. The statements like all A's are B's and some B's are C's that we saw earlier are part of a kind of syllogism which is called a categorical syllogism. A syllogism is a kind of logical argument in which a conclusion is deduced from the given statements or premises. A premise or a proposition is a statement that is assumed to be true. We can see a lot of questions based on categorical syllogisms in aptitude tests. A categorical syllogism is a kind of syllogism in which we try to deduce relationships between categories or sets based on the given relationships. You should understand that categorical syllogism is just one type of syllogism. There are other syllogisms or logical constructs like conditional syllogisms, disjunctive syllogisms, etc. However, when we say syllogism, the most commonly meant idea is that of categorical syllogism. We shall restrict this discussion here to categorical syllogisms and leave the others for the later. Let us focus on categorical syllogisms. A categorical syllogism is a kind of syllogism in which we try to deduce relationships between categories or sets based on some given relationships. A set or a category is a group of elements with a common characteristic. Examples could be tables, chairs, pens, eagles, birds, mammals, reptiles, animals, flowers, trees, metals, men, women, A, B, C, D, etc. Two sets or categories P and Q can be related in 8 standard ways as shown in the slide. They are: all P's are Q's, all Q's are P's, some P's are Q's, some Q's are P's, no P is Q, no Q is P, some P's are not Q's, some Q's are not P's. Here, the terms all, some, no, and some are not are called qualifiers. Based on qualifiers, the statements can be classified into 4 as given in the slide. In statements like all A's are B's, every A is a B, any A is a B, etc., we are saying that every element of A is also an element of B. Since we are talking about all elements of A, it is a universal statement. Since it is a positive statement devoid of negative terms like no, none, etc., it is an affirmative statement. Affirmative means positive. So we can classify such statements as universal affirmative statements. In relationships like some M's are N's, many M's are N's, etc., we talk about only some elements of the set M, and so it is called a particular statement. Since it is not negative, it is particular affirmative statement. In statements like no X is Y and none of the X's are Y's, we are saying that none of the elements of set X is an element of set Y. Since we are talking about the entire category of X, it is a universal statement, and since the statement is negative in nature, it is a universal negative statement. In statements, some C's are not D's and many C's are not D's, we talk about some elements of set C which are not elements of set D. Hence, it is both particular and negative. So it is classified as particular negative statement. Now that we have a base idea about standard relationships between categories and their classification, let us look at some typical syllogism questions and learn how to approach them. Look at question Q1 given in the slide. The two statements or premises given are all cats are rats and some cats are dogs. Based on these, we need to find the relationship between the categories rats and dogs. Before we see how to address this question, a few things need to be noted. Here, please do not ask the question, how can all cats be rats? From our experience, we know that cats and rats are different, and all cats are rats cannot be a true statement. We usually take them as different. In syllogism-based questions, these kind of statements are quite common. They may say, all apples are oranges, none of the Malayalis are Indians, some elephants are trees, etc. It is just to avoid the monotony and boredom that occurs when we say all A's are B's, no P's are Q's, some X's are Y's, etc. So when you see such statements, do not give the real life meaning to these terms. Just take them as a set whose name is cats and another set whose name is rats, which are related as all cats are rats. So, the question is to be understood as follows. There is a set or category called cats and another set or category called rats which have the relation all cats are rats. There is another set called dogs which is related to cats as some cats are dogs. We need to take the given statements or premises to be true. Based on these relations, we are asked to find the relation between the sets rats and dogs. Now, if you observe the statements once again, you can see that the term cats is common to both the premises or statements. We are trying to find the relationship between the non-common sets eliminating the common term cats. Here, the category cats is called the middle term because it occurs in both the statements. Naturally, the other two, rats and dogs, are called non-middle terms. There are two standard approaches to solve categorical syllogism questions. One is a diagrammatic method and another is a rule-based method. In this discussion, we shall look at the diagrammatic approach. In the diagrammatic method, what we do is to draw diagrams that represent the given relationships and then combine the diagrams in order to deduce the relationship between the categories in question. Let us use diagrammatic method to answer question Q1. First, let us try to represent the relationship all cats are rats diagrammatically. The diagram figure 1b shown in the slide is the one that comes naturally to all of us when we say all cats are rats. However, there is another possibility also, which is shown in figure 1a. This happens when cats and rats represent the same set of elements. That is, when they completely overlap. Now, which of these is the correct representation? Both of them are. The relationship between cats and rats given to us is all cats are rats. In both the figures, figure 1a and figure 1b, the relation all cats are rats is true. If it was known that all cats are rats and further all rats are also cats, then we will be able to fix on figure 1a. Similarly, if we have to say for sure that the situation is as in figure 1b, we need to know that all cats are rats and some rats are not cats. If we have these two statements, figure 1a will not be correct and we can say that figure 1b is the only possible diagrammatic representation. However, with just one statement connecting cats and rats, namely, all cats are rats, we will not be able to say for sure whether figure 1a or figure 1b represents the actual scenario. Both are possibilities, and so we should consider both of them. Look at the second premise. Some cats are dogs. The possible diagrams that represent the relationship are given in the slide. The figure 2a is the one that naturally comes to all of us. There is no need of explanation there. There is a set of elements called cats and another set of elements called dogs, and there is a common overlapping area which represents elements which are part of both the sets. Look at figure 2b. The set cats is shown in light blue. Some of those are dogs. Here the set dogs has been shown completely within cats. That is also a possibility, isn't it? Figure 2c may raise a few eyebrows. You may argue that it represents all cats are dogs. True, the diagram 2c can be used to represent all cats are dogs. But that is not a representation of only all cats are dogs. That is a possible representation for some dogs are not cats as well. Look at it this way. If someone looks at figure 2c and says, some cats are dogs, can you say that that person is wrong? No, because if all cats are dogs, definitely the statement some cats are dogs will also be true. For the statement some cats are dogs to be true, the condition is that there should be at least one element of the set cats which is also a member of the set dogs. That is, there should be some overlap between the sets cats and dogs. Similarly, figure 2d also is a possible representation of some cats are dogs. Over there, all cats are dogs and all dogs are cats. Looking at that figure also, I can say some cats are dogs because in that diagram, there are members of set cats which are members of set dogs. Now that we have seen how to represent the given premises diagrammatically, the next step is to combine the diagrams representing the two premises and find the relationship between the non-middle terms rats and dogs. We saw that we can diagrammatically represent the relation all cats are rats in two different ways and the relation some cats are dogs in four different ways. Remember that our aim is to find the relationship between the non-middle terms rats and dogs. Recollect that a middle term is the term that occurs in both the premises, cats in our question. The other two terms, rats and dogs, are called the non-middle terms. As we had seen earlier, there are 8 standard relationships possible between rats and dogs. They are all rats are dogs, all dogs are rats, some rats are dogs, some dogs are rats, no rat is a dog, no dog is a rat, some rats are not dogs, and some dogs are not rats. Now we have to go through the different combination diagrams and see which all among these will hold true in all the combination diagrams. A combination diagram is obtained by combining a diagram representing the first premise and a diagram representing the second premise. So we will have combination diagrams like figure 1a, 2a, 1a, 2b, 1a, 2c, etc. Go through the different combination diagrams. 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 Note that for a relation between rats and dogs to be valid, it should hold good for all the combination diagrams. Being true in some of the diagrams only is not sufficient. This is because each of the combination diagrams is a possible scenario, and for the relation we deduce to be universally valid, it should be valid in each and every diagram. Now that you have glanced through the combination diagrams, let us look at some of those once again and see which of the 8 standard relationships given in the earlier slide will be valid across all the combination diagrams. Let us look at first of the possible standard relations between rats and dogs, all rats are dogs, and check its validity across all the combination diagrams. On visual observation, we can see that all rats are dogs will not be valid in figure 1a, 2a itself. Now, since it is not valid in one of the combination diagrams, we cannot take it as a valid relationship. So we look at the second possible relationship, all dogs are rats. That also is not valid in figure 1a, 2a. So we look at the next possibility, some rats are dogs. We can see that this will be valid in figures 1a, 2a and 1a, 2b. Now look at figure 1a, 2c. There, the set rats is completely within dogs. So ideally, we should be saying all rats are dogs. However, if we make a statement, some rats are dogs looking at this diagram, it will not be wrong because if all rats are dogs, definitely some rats are dogs. Similar is the case with figure 1a, 2d and figure 1b, 2c, 3. In all the other diagrams, we see that the relationship some rats are dogs will be valid. So, some rats are dogs is a valid relationship between rats and dogs. Now take the relation some dogs are rats. On observation, you can see that it will also be valid in the same way as some rats are dogs. In fact, it is worth noting that the relationship some A's are B's and some B's are A's are interchangeable. Now let us see whether any of the other standard relationships will be valid. Take the relations no rat is a dog and no dog is a rat. We see that those will not be valid in any of the diagrams because in no rat is a dog and no dog is a rat, the sets rats and dogs should be disjoint. That is, they should not be touching each other because in no rat is a dog or no dog is a rat, they will not have any common element between them. Now look at the last two of the standard relationships. some rats are not dogs and some dogs are not rats. The relation some rats are not dogs will not be true in figures 1a, 2c and 1a, 2d. And some dogs are not rats will not be true in figures 1a, 2b and 1a, 2d. So, the relationships which are valid across all the combination diagrams are some rats are dogs and some dogs are rats. I am sure that you would not disagree with me if I say that this elaborate approach that we took is not very suitable for an aptitude test situation, where we need to do questions quite fast. However, there are some important points that you should learn from the detailed approach we took in solving this question. They are: 1. There may be more than one diagrammatic representation for a premise. In this question, we had 2 possible diagrams for premise 1 and 4 possible diagrams for premise 2. Point number 2. When we combine the various diagrammatic representations of individual premises, we will get a large number of combination diagrams. 3. A relationship that may be true in certain combination diagram need not be true in another. Point number 4. In order to say that a relationship between two sets is valid, it should be valid in all the combination diagrams. And point number 5. If a relationship between two sets does not hold good in any of the possible combination diagrams, we can say that it is not a valid relation. The approach we took to answer question Q1 was a long drawn and elaborate approach. This would have fetched you maybe 15 marks in a university or board exam. But in an aptitude test situation, where we try to attain one question per minute kind of speeds, this approach is not suitable. Moreover, there will not be sufficient space in the rough sheets or question papers to draw all the possible diagrams and their combinations. So if you are doing syllogism questions using diagrammatic method, you should work smartly and use a bit of your imagination to cut short on the time and space requirements. Now we shall look at how to do that in the next presentation. The trick is to work with just one diagram to represent a premise and imagine all other possibilities in the canvas of your mind. Please take a look at the next presentation to understand how to do that.